So in this video we'll be going through freezing point depression and boiling point elevation. So the formula says the freezing point depression is noted by T of solution, which is the final temperature of the solution, is equal to T of solvent minus delta TF, and delta TF is the freezing point depression. So this is the symbol denoted for freezing point depression, is equal to K of F, which is always going to be given to you in the exam. So it's a constant from the table, you have to find it, and M here is the molality. So now molality is the number of moles of solute over the liters of solvent. So I had explained molality before and comparing it to molarity. So this is the formula, and we'll be going through examples, so this will be more clear. And the boiling point depression is the same formula, except that you are plussing the boiling point depression here, and the formula is the same. Now the main difference is that you have to identify if it's an electrolyte or a non-electrolyte. So whenever it is an electrolyte, you need to count the number of ions in the equation, and you need to include it in the formula. If it's a non-electrolyte, meaning that there's only one ion, so you can ignore the I here. So now let's see some examples, so this will be more clear for you. So in this first example, we are to calculate the freezing point of a solution containing 0.13 moles of a non-electrolyte. So this is very important. So there's only one ion, meaning that we'll just use the original formula. Solute in a 2.5 kg of benzene. So the solution, the solvent, is benzene. So here let's write the formula here. So I just wrote the formulas to make it more clear. So first of all, we have to find, what are we supposed to find? We have to find the freezing point of the solution. So here we are finding T of solution, not delta T of F, which is the depression, freezing point depression. So this is also another point where students get confused. So let's start here. So the first thing is to find delta TF. So we have the K of F here given in the question, and we need to find the molality. So now let's find the molality. So we just do the formula, we use the formula here, which is number of moles of solute over the liters or kg of the solvent. So I just put the values here, 0.135 over 2.5, which will give you 0.054, and now we can find the delta TF, which is just times in K of F. So delta T, okay, let me just write it. So I just use the formula here, which is 5.12 times 0.0454, and it's giving me the value of 0.276. So now the final step is to just do T of solvent minus delta TF. So the delta T solvent is given you as 5.5 here. So the final step is just substituting the values again. So here I just did the final step, which is T of solvent minus delta TF, and you will get the answer of 5.224 Celsius. So don't forget the unit. And now you might be wondering, K of F and K of solvent. So this is either given you as this, or it will be given you in a table, and you have to find the corresponding value. So might be water is like this, and benzene is like this, and then this is K of F, and then this is T at solvent. Yeah, so you just find the corresponding values. So now let's move on to the next question. So here we have it's a kind of a confusing question. So now it's asking you which solute was added to 1 liter of water if the solution boils at 106.4 Celsius. So I'll just underline the important things here. So first of all, we know the solvent is 1 liter of water. It boils at 106.4 Celsius, and initially poured this much of it without remembering it was. So what we have to find is the solvent. So now again, let's write the formulas to make it more clear. So here I just wrote the formula, and to simplify, I will just identify which value responds to which value. So here we have the T of solvent, which is 100 Celsius, since the boiling point of water, which is the solvent, is 100, and the Kb is given as 0.512. So this is Kb. So now let's see where all these values are going. So first of all, we have 106 I'm talking about the first formula here. So 106.4 is equal to 100 plus x. So x here is delta. Okay, you know what? I'll write delta TB, and you get delta TB to be 6.4 Celsius. So now using this, we can use this formula now to find the molar mass. So now let's break this formula down into more dense, so we can find the molar mass. So here we can write molality as, give me a second here. So here we can write m, which is molality, is equal to, okay, I wrote this wrong. Yeah, so times, so it's going to be number of moles of solute over solvent. The solvent is 1 liter, and you can break this down even more further into, so I just wrote n as mass over molar mass, and what we have to find is the molar mass, and the mass is given to you as 575 grams, and kb is also given. So now you can just write the final equation, which is going to be, so this is the final equation, and you can do shift solve on your calculator to find the molar mass, which is a very fast way to do, and you will get the molar mass as 46. So now you can just find the molar mass of each of them, and whichever is 46 here, so that will be the answer here. So here in our case it's going to be this one, this butanol. So C2 times, so just let's do it quickly, times 12 plus 5 plus 16 plus 1, which is giving you 46 exactly. So this is the answer. So butanol is the answer here. So till now we only have dealt with non-electrolytes. So what if there are ions in the electrolyte? So now let's go into another example here. So in this example we are calculating the freezing point depression and boiling point evaluation of 0.53 NaCl. So this is very important now. So this is an ionic solution, so which means that there's ions in it, which are two here, which is Na here and Cl. So there are two ions here. So now we will be using the second formula for electrolytes, which is basically with the I here, and I here will be the number of ions here. So you just times the delta Tf, depression point, boiling point depression, I do not, or freezing point depression. So everything is going to be the same, except that in this formula, delta Tf, you times the number of ions here, which is 2 in this case. So now let's just write it out. So these are the Kf and Kb constant values. So we just substitute that here and find the answer. So let's do that now. So after substituting we get this, and now the final answer for freezing point depression will be 2 Celsius. So you have to be very careful if it's asking you the freezing point depression or they're asking you the final freezing point. So there's a very big difference. So they might ask you T of solution, or they might ask you delta Tf, which is the freezing point depression. And now for boiling, it's the same thing, but you just do delta, the Kb will be different here. That's it. So here's the equation, and the final answer is 0.54 Celsius, and this is the boiling point evaluation. So that's all for this video. If you have any questions, you can ask in the comment section. I'll be happy to answer them, and thank you for watching.